right? Section 1.1, part 2. So we have all kinds of vocabulary words for part 1. So now we're going to have 4 new ones, actually 7 new ones for part 2. Okay, so the first one is distance. We've used the word distance before. We're just going to give it a more formal definition. And we've used it in everyday life. And someone's like, hey, what's the distance between Macintosh and Mobridge? Okay. Distance between 2 points is the measure of the length. So we're really measuring how long. The measure of the length of the shortest line segment that would connect them. Okay. So if I'm talking about the distance between 2 points, which normally we denote distance as 2 points without the line segment above it. So here, if I just write AB, this is me wanting the distance between A and B. So if I want the distance between A and B down here, this point A and this point B, I'm going to measure how far it is from the segment here to here. I'm not going to measure how far it is to go ooh, there, right? I could go a roundabout way and have it take me as many miles as I want to get from A to B, but that distance is that shortest distance from A to B. Okay. All right, so now we have collinear and coplanar. I'm going to go ahead and dig out my highlighters for this bit. First, I'm going to highlight the word in the middle here, line. This has the word line in it, and this one almost has the word plane. Plane in it. Collinear is they lie on the same line. Are on the same line. Okay. So for example here, should have used a ruler there, sorry. Points A, B, and C are all collinear because they're on the same line. So if collinear means on the same line, coplanar means on the same plane. So on the same plane. So if we go ahead and draw our little plane here, coplanar, M, N, P. There is my coplanar. Okay, coplanar doesn't always have to be points. You can have a line. Here, this line, lowercase b, is coplanar with point M, N, and P. Coplanar just means on the same plane. Okay, apostolate. All right, this is a new word, apostolate. Apostolate is really a statement accepted without proof. Meaning it's a statement that we just agree is true without a formal proof. And we will define and look at what a formal proof looks at like, but it's just a statement that we accept without proof. So here is our first postulate. We're going to learn a postulate today. It's a real toughie, but for some reason, this is the one that people tend to forget, and we use it a lot. It's the segment addition postulate. Basically, it's saying if I have 3 collinear points, so A, B, and C are all on a line, and if B is in between A and C, then I know that this distance, so here, this means the distance from A to B, this distance from A to B, plus the distance from B to C equals the whole distance. So basically, this is telling me if I take 2 parts of a segment and add them, I get the whole segment. And you might say, hey, no duh, but we use this no duh statement a lot in proofs. Okay, so we're actually going to use it now to do what's called a geometry construction. A geometry construction is basically creating a shape or figure using nothing but a compass and a straight edge. To do a construction, you are not allowed to measure. So when it says construct, no measuring. Measuring always has room for error. There's always an error when measuring, and you discuss that in science, how much the error could be based on the unit of measure. Okay, but if here I want to use a compass and straight edge to construct a line segment with lines at AB plus CD. So I want to draw one segment that is these two pieces added together. Okay, so I can't come in and measure because I always have some rule, there's some error there. So what I'm going to do is I'm going to take, so here's how we do a construction, and I want to construct, so I want to construct a length of segment A to B, and then one from C to D, and I'm going to show you how to do that using the compass. The first thing I'm going to do is I'm going to eyeball, and I'm going to draw one that I think for sure is long enough. So I'm just going to eyeball, like if I took this and added it onto that, it's almost going to be the full length of my paper. So I'm going to go ahead and I'm going to use my template because it's longer, and I'm going to draw a preliminary line kind of all the way across my paper. Okay. So now I'm going to put a copy of point A down here. So I already have a point A in my drawing. I can't have another point A. You can't have two Kevins in the same room. So I'm going to go ahead and I'm going to call this A, and I'm going to put a little notch on it. That's what we refer to as A prime, a copy of A. So now I need to figure out where B prime needs to go. This is where my compass comes in. I'm going to take my compass. I'm going to put the pointy part on point A, and I'm going to stretch my pencil out until it hits point B. So there is how big A to B is from there to there. So now without moving my compass, I'm going to come down here without changing how wide it is. I'm going to come down here. I'm going to put it on A prime, and I'm going to do a little, what we call a little arc or notch on where B prime should be. So B prime should be here. So there is my line segment distance from, so here what I did is I just basically made a copy of this segment down here. So from here to here would be the same length from here to here. And I can double check it by putting my compass up here, measuring from here to here, and put my compass in here, measure from here to here. Okay, so yes, they are the same. Now, that's A to B. We want A to B plus CD. So I'm going to have this point I named B prime. I'm also going to give it another name. I'm going to call it C prime. That's where C prime is going to be. So now I just need to repeat and put C to D here. So I need to measure how far is from C to D. So again, I put my pointing pointer part C. We stretch my compass out till it hits right at point D. So right there, maybe a little bit farther. If your compass is too loose, let me know. All it takes is a Phillips screwdriver to tighten it back up. There we are. There's C to D. Now, again, I come down, I put my point at B. See, and sometimes it's helpful to move the compass. I like to move my paper and keep my compass hand still. And there's where D should go. You can see it very lightly over there. Draw your arcs light. It's much easier to use a compass with low pressure. So there's D prime. So then I come in, this is why we use a pencil, and I can erase all the way up to D prime. So there is my new segment. This segment is the same length as this plus that. So there's my new one. Good job on your first construction using our compass. Woo-hoo. Okay, now we have 3 more new words. I know, full of new words. Okay, congruent. Congruent is just our geometry way of saying equal. Basically, congruent have the same measure. Same distance, same length. They have the same measure. So congruent here, AB was congruent to A prime, B prime. The congruent symbol is like an equal sign, but with what we call the tilde above. Okay, this is only used for symbols or items. So I would say here, segment AB is congruent to segment A prime, B prime. They are congruent because they have the same measure. I have no idea what that measure is. I didn't actually measure it, but I know that they're congruent. They're the same. So they have the same measure. We use the congruent symbol to show two things are the same. we use the equal symbol to denote us two numbers. So the difference here, this symbol above tells me that this is a thing, it's a segment. This does not have a symbol above. This is a distance, it's a number. This is a distance, it's a number. So we use an equal sign. The equal sign is used, numbers are equal, numbers are the same. Whereas we use the congruent symbol when two items or things are the same. Okay. All right, bisect. Bisect is divide it into two equal parts. Cut it in half is our layman's term. If I cut it in half, I bisect it, and the thing that cuts it in half is called the bisector. Okay, so a midpoint is a point that bisects a segment. It is that point that bisects a segment. So bisect is really a verb. It's something that you do. If I'm going to bisect an angle, it's something I'm doing to an angle. Bisect a segment, something I'm doing to a segment. A midpoint is a noun. It's the thing that bisects. Okay, kind of the difference there. All right, so we are actually going to learn another construction. We're going to use a compass and straight edge to bisect a segment. So first we need a segment. Okay, I'm just going to come in and I'm just going to go ahead and draw a segment. There in the middle of my page using a ruler. I don't know, let's call this segment M to N. And we want to bisect it. Bisect, cut in half. Find its midpoint. Cut it in half. Okay, so here is the compass way. Again, no measuring. I can't use a ruler or measure, figure out what the midpoint is. No measuring. Construct. Okay, so what I do is I take my compass and I put it on one endpoint. I stretch out farther than halfway and I draw one big arc. And notice how I'm moving my paper. I'm not actually moving my compass. It's my paper that's moving, guys, not the compass. Now, without changing the size of my compass, I'm going to switch hands and I'm going to now put it on the other endpoint. And I'm going to do that exact same process. What I'm looking for are these 2 points where it crosses. Sorry, that got blurry. I'm looking for these 2 intersection points. Once I have those 2 intersection points, I come through with my straight edge. I line up those 2 intersection points and connect them. I have now bisected this. So now this point here is the midpoint. I have now bisected this. So if I call this point P, I know that MP is congruent to PN. P is the midpoint. Isn't that fun?